So hello everyone, welcome back to the channel. So in this video I'm going to teach you binary search. So why we need binary search, like we have a linear search, then why we required to use or why we use binary search. So basically binary search is not used for all type of arrays. Basically it is used for only the array which are sorted in ascending or descending order, that is increasing order or decreasing order. So now first, what is linear search? So basically what linear search do is that it will go to each element. Suppose we are finding like we want to find a element 12. So what it will do is that it will go to first element and check if it is 12 or not. Then it will go to 5 and check if it is 8 or 12 or not, and it will go to these and then these and these and these. So basically when it will find 12 it will return. But for the worst case, suppose the 12 or suppose it is asking for 38. So 38 is at the last index. So in that case the complexity, or in the worst case the complexity will be on. So to improve these in sorted arrays we use binary search. Now let's understand what binary search do. So we will take this array and we will copy paste here. So like what binary search do is that it will partition the array into two. So here the partition will be, these will be the left array and these will be the right array. So basically we will partition through a middle element. We will take a middle element and then we will divide the array into two. One is left subpart and another is right subpart. So yeah, so as we know that it is a sorted array. So suppose we want to find 23 in the array. So it will compare the 23 to the middle element. So it will check if 23 is greater than 12 or not. So in that case it is. So what it will do is that it will eliminate the left part, because if the element that we are searching for is greater than 12, so it can be less than 2, 5 or 8. So in that case we will eliminate this whole of the side, and then we will go to right. And in that procedure we will compare the element each time to the middle element. So here we will compare it to the middle element, and if it is equal to the middle element, then we will return the return true if it is if it exists here or not. So again we will go to left subarray, and what we will do is we will partition again. So here we will 23 will be middle element here. So we will again partition it into two parts, that is 16 and 38, and we will first check if 23 is the value that we are looking for. So in that case it is yes, so we will return true because it exists. And if suppose we are looking for 16 or 38, so in that case we will, if we are looking for 16, then we will eliminate 38 and we will go to 16. That's the only element in the array. So we will find we will check if it is the element, then we will return true, and if it is not, then the loop will end and it will exist. So basically what it do is it will compare the value that we are looking for to the middle element of the array, and if it is greater than, then we will eliminate the left sub array, or we can say the left part of the array from the middle element. And if it exists in the right left part, like smaller value, then what we will do is we will eliminate this part. So now let's understand the code for these. So here suppose we want to find the number 12. Yep. So here what we will do is first we will take the value and target value, and so first we will get the size of the array so that we can point the last pointer to that. So for that, suppose first check the left pointer, what it will point the 0th value, the first index here, and then we will take the right, it will n minus 1, it will point to the last value. And for now we will iterate in the loop, and if we will check if left, the loop will run until left is less than the right. So if that like this pointer is here and the right pointer is here, and it will goes here and it will go here, or suppose it will partition it and it will become here. So when the left pointer crosses the right pointer, then the loop will end. So now we will find the middle element. And how we will find the middle element? By summing of the first and last index. So for left plus right, and then what we will do is we will divide it by 2. That is, we are dividing both the arrays into equal parts. So here 12 is the middle. So for the left plus right and then divide by 2, so we will find 12 as the middle, and then we will partition the array. Now what we will do is we check if the target we are looking for is equal to the value at the mid index. If that is the case, then what we will do is we will just return true. Else if, so suppose the target is not equals to nums, and what we will check is like we will check if the target is less than to the middle element value. So suppose here the target is less than nums mid. So here what it is that the target is less than the middle value. So in that case, what we will do is we will eliminate the right part. And how we can do it? We will shift the right pointer to the middle element -1. So here 12. So here suppose like we are looking for 8. So what here is that we are comparing it 12. So the target is less than 12. So we will shift the right pointer that points this to this, because the value is smaller than the middle, and then the right will be here, the low pointer will be here, and we will again calculate the middle for that. So we will find 5, and then again 2 and 8 will be unseparate array. Now the last, that is the case where the target is greater than nums mid. So here we are looking for 23. So here the target is greater than 12. So in that case, what we will do is we will shift the left to the left pointer to the middle +1. Suppose we are looking for 23 here, so we will compare 23 with 12, and if it is greater, then we will eliminate this part and we will go to right. So here it will become left, the pointer shift to 16, the left pointer, and the right will still be at 38, and then it will find to 23, and then again it will do like this, and we will return in the array. And if it finds the value, and if it doesn't find the value and the loop ends, we just simply return false. We will just simply return false, that we doesn't find the value. Now let's run the code. Yes, it returned true because the value exists. It will just return, or we can say like, and like give some that is not in the array, like 62, and now if we will run it will return false, that is the value doesn't exist in the array. So that is binary search, and the complexity for binary search is logarithmic of n, because each time we partition the array becomes smaller and smaller, so we don't have to iterate to each element in the array. So it will make the complexity to logarithmic n, and that's why we use binary search for sorted array. Now that's enough for the video, and thanks for watching the video. And if you do like the video, make sure to subscribe to the channel, and take care. Bye.